Hey Excel warriors, today we'll be looking at XLookup's optional arguments and some advanced techniques to really take your lookup skills to the next level. But first, in case you're new here, hello and welcome to the channel. My name is Elliot and I make videos all about Microsoft Excel. I'm sharing everything I've learned to my journey from an Excel beginner to reaching the final 32 in last year's Microsoft Excel World Championship. This year, I'm hoping to take it all the way to the Grand Finals live in Las Vegas, so make sure you subscribe to the channel as I'm sharing everything I've learned as well as everything I'm doing to prepare for this year's competition so that we can excel together. Last time, we talked about why XLookup was a better choice than some of the older lookup functions such as VLOOKUP or index match, as well as covering the basics of how to use it. In this video, we'll cover those optional arguments as well as how to do a 2D lookup using XLookup's dynamic array functionality. First, we'll do a quick review of XLookup to make sure we're all on the same page. If you're feeling a bit left behind, make sure you check out that previous video, but in essence, all you need for XLookup is to specify a lookup value, a lookup array, and a return array. By default, it assumes you want an exact match, so you will get what you want every time. Before we dive into those optional arguments, I want to cover one of the advanced techniques, which is XLookup's dynamic array functionality. Dynamic arrays are becoming more and more common in Excel, with many of the newer functions having dynamic array capabilities. Simply put, dynamic arrays let you return more than one result at a time, as seen with this sequence function here. This means that your data can respond to other changes within the workbook without you having to specify a different row for each thing you want to do. There are two main ways XLookup uses dynamic arrays. The first is by passing multiple results in as your lookup value, you get multiple results returned as if you'd look them up one by one. This is useful if you're looking at multiple values as you only need one formula in one cell to return all of the results. And you can even pass the result of a different dynamic array in as that first argument to have truly dynamic data. Because this is a formula entered in just one cell, you don't even need to worry about locking those references. The other dynamic array functionality lets you return multiple columns in one result. To do this, you simply extend your return array to cover more than one column. For example, if we look up Rory and return both columns E and D together, we can get his profession and his Excel skill just from one formula. This opens up a new possibility. Because we can return multiple columns, we can actually do a 2D lookup. We're going to need two lookup functions here. We're going to start with the inner function. That inner function is going to look up a name and return all of the attributes from the table. We're then going to wrap this in a second XLookup, which looks up the skill we're looking for within the headers and returns from the dynamic array returned by that inner XLookup. This gives you the flexibility to look up a value anywhere within a 2D table, which previously you would have had to have used index match to accomplish. But of course, because XLookup is way simpler, this is much easier to explain and use in your workbooks. Now let's talk about the optional arguments one at a time, starting with the first not found. If you were to look up a value that doesn't exist in the table, you would get the dreaded NA error, just like we have for poor Ricky here. This is the same result you would get if you used VLOOKUP or index match, assuming you remember to tell it you didn't want an approximate match. This is messy and can cause odd results from other functions further down the lines, and just leads to a cluttered looking workbook. Historically, I've seen people solve for this by wrapping the whole thing in an if NA, or even worse, an if error. This can clean up your workbook because you can choose to return a blank string in place of an error, but the errors exist for a reason. They tell you something's gone wrong, and if you hide them, you don't know what you could be sweeping under the rug. Sure, it might just be something as simple as it doesn't exist in the table, but it might be the table itself has got a wrong calculation in it, and you're hiding that in your results. Luckily, XLookup has a built-in solution with the not found argument. This argument lets you specify what you want it to return if the thing you're looking up does not exist in the table. This could be whatever you like. It could be a blank string, a custom message, a specified value such as 0, or even a calculation from elsewhere, such as here, where we're using the average Excel skill from the table. This turns XLookup into an imputing tool alongside all its other capabilities, and also is a lot cleaner than using if error or if NA. Next up is match mode, which lets you specify whether you want an approximate match or an exact match. Now I know I went on and on before about how the exact match default behaviour of XLookup was one of its advantages, and that is true because most of the time you do want an exact match. However, there are scenarios where using the approximate match can be really useful and really powerful, and XLookup's match mode argument lets you specify whether you want an approximate match matching on the next biggest or the next smallest match. This is great if you're trying to assign a category for something based on a score, whether that is assigning grades based on boundaries, or even working out how many boxes you need to ship an order. In this example, we have a list of books and the number of pages for each book. I want you to take a moment to think about how you would approach it if someone asked you to categorise these books based on their second table. Would you reach for a series of if statements all nested inside each other? Maybe you'd be a bit more modern and go for the ifs. Maybe you'd use index of the categories and then do some calculation to work out which one to choose. All of these are valid approaches and will work. However, they can be difficult to dive into if you come back to it after a few weeks, particularly if you need to update what's going on. We can make this really simple using just XLookup. We're simply going to use a lookup value of the number of pages, look that up in the lower bounds, and return the category. We're going to enter 2 commas to tell it we don't care about the not found argument, and then for match mode we're going to set that to -1. The -1 says if it doesn't find the number of pages in that list, find the next smallest match. This gives us dynamic categories in one simple formula. It's way easier to read, and to update it you just change that table to the right without having to worry. If you needed to add more rows, all you would do is extend that table down and extend the lookup and return ranges accordingly. There are even ways to make it so you don't have to update those by using tables, which we'll cover in the next video. You can also change match mode to the value 2. This allows it to search using wildcard symbols. Wildcards can be a bit confusing, so we're going to save that for the next video, so make sure you check that out if it's something you think might apply to your work. Finally, we have the search mode argument. This lets you specify how XLookup looks through your data. By default, this is set to 1, which looks from the top of your data all the way through to the bottom, returning the first match it finds. Alternatively, you can set this to -1, which will be a bottom-up search. This has been really useful in competitive Excel, particularly when you've had game-style scenarios, such as people playing cards or a board game where they're having alternate goes, where you want to get the last go of a player. It can also be useful if you have a table where new rows are added over time, and you want to get the last entry in that table. However, it's not the most robust approach to getting the latest entry in a table, because if someone resorts that table, you're going to get a different result. We're going to cover helper lookups in the next video, where you need to match based on 2 different columns at the same time, such as matching for an entry and the date it was added. There are 2 more options for search mode. You can set it to 2 or -2. This tells XLookup you want it to use a binary search to find your value. Now, this isn't a computer science video, but bear with me. Unlike a linear search, which searches from top to bottom or bottom to top, binary search starts in the middle of your data. It compares that middle value in the table to the value you're looking for. If it's a match, great, it's done. If the thing you're looking for is more than the thing that you've found in the middle, you know that your data must exist in the second half of that table. So we can ignore the first half and just focus on that second half. It then repeats the whole thing, starting with this second half only. It chooses the middle value of the second half and then decides whether the value you're looking for is in the upper or bottom half of that second half. And it keeps going until it finds the value you want. This is slightly slower for things early in the list, but on average it is way faster. For those computer nerds out there, it changes the time complexity from O of n to O of log of n. However, as you may have already clocked, one of the requirements for this is that your data is sorted by the key column you're looking up in. Otherwise, there is no guarantee that just because what you're looking for is bigger than what you found, it's going to appear later in the table. A 2 is for binary search, where the key is sorted ascending, and a -2 is for when it's sorted descending. Binary lookups significantly reduce the number of comparisons that Excel has to make in order to perform the XLookup. This is really useful in workbooks with thousands and thousands of rows where you're having to look values up multiple times. In reality, you won't have to reach for it very often, but it's great to be there for those times when you do. That's all for this video on XLookup optional arguments. I hope you found it useful. If so, let me know in the comments below. Make sure you join us next time because I'm going to be talking about helper lookups as well as named ranges, tables, and things like using exact for case-sensitive lookups. Until then, thanks for watching and keep excelling.